Kia ora, Year 12 and 13. This is question 2e from the 2013 integration paper. It's a nice question where we have to find the area between two curves, and we're given limited information to do that. So it really tests your understanding of some of the level 2 calculus concepts. We've got a curve, and the curve passes through the origin. Now that's extremely useful to us because you can pin down your plus c by knowing one point on the curve. We're given the gradient of that curve as this function, and we're told that the line on the graph that we're looking at is the tangent to the curve at x equals -1. So the steps in this question go like this, not necessarily in this order, but we might as well find f of x straight away, and then we're going to find f dash at -1, right, because we need to get the equation of this line, and then we're going to find the equation of the tangent. We'll do that using this. So that should really say use. And then lastly, the very last bit is the integration part. Now we're integrating between two curves. So we're just going to use this limit of integration in this one. And we're going to find this, the integral between 2 and -1 of the top minus the bottom line. So it's going to be f of x, because everywhere in that region the curve is above the line, minus the tangent equation, right? Now notice that the tangent equation is not obviously the same as just the gradient function. Okay, so let's get on with it. We've got f dash of x. Just trying to find my bits of paper. F dash of x is equal to 1 minus a third x squared. So f of x will be x minus a ninth of x cubed plus c. But because we know that 0, 0 is on the curve, we know that 0 is equal to 0 minus 0 plus c. So c is 0. So that's great. That means that f of x is equal to x minus 1/9 x cubed. So that's step 1 done. Now the next thing we have to do is to get this equation of the tangent line. So we need to evaluate the gradient at x equals -1. So f dash of x again is equal to 1 minus 1/3 x squared. F dash at -1 will equal 1 minus 1/3, which is 2/3. Right, so now we should be good to go to find the equation of the tangent at x equals -1. Except I'm trying to think if I already did. No, I didn't find the value of the function at -1. Let's do that first. So f at -1 will equal 1. No, it won't. Where's my function? Too many functions. So I'm substituting -1 in here, right? X minus 1/9 x cubed. So it's going to be -1 minus 1/9 of -1 cubed, which is -1 plus 1/9, which equals -8/9. So let's just go back to the picture and see if that makes sense. And it does, right? Because you can see that this line looks like it's got a slope of about 2/3. And this point here looks like the y value is a little bit above -1. So that's all looking quite good. So finally, y minus y1 is equal to m times x minus x1 will give me my tangent line. So y minus -8/9 is equal to 2/3 of x minus -1. Just make sure when you're doing questions like this that you do check your working back to make sure you haven't dropped any negatives. So it's going to be 2/3 x plus 2/3 minus 8/9, which gives me 2/3 x. There is my piece of paper. 2/3 of x plus, so that's 6/9 minus 8/9. So 2/3 of x minus 2/9. So that's y, that's my tangent line. So now we're ready to integrate. And the area is going to be the area from 2 to -1 of the curve, 1/3 x minus 1/9 x cubed minus the tangent function. So cleaning that up first gives me what? Let's see. Sorry, I've made a mistake in there. That's not 1/3 x, that's just x. Okay, so from 2 to -1, 1/3 x minus 1/9 x cubed plus 2/9. So a very, very easy integral. All of the thinking in this question is in the earlier part. Right. So we end up with this. So back to level 2 integration now, and be careful again with your limits. So substituting in here, we'll get 4/6 minus 16 on 36. I bet everyone's turned off their video and isn't watching this bit now. It's really easy to muck it up at the very last step, and then you're going to end up with a merit, which would be a bit sad. So you're going to have minus 1/6 minus 1/36 minus 2/9. So I cleaned those up into two fractions, common denominator of 36. And we've got 24 minus 16 plus 16 minus 6 minus 1 minus 8. That gives us 24/36 plus 3/36, which gets me to my final answer of 3/4. So there you go. I think it's quite a nice question. It's easier than the cylindrical tank one that I just did in some ways, but you have to have your wits about you to figure out the equation of the tangent. So you just have to be really good at linking up all of those ideas that you learnt probably a year or two ago now, and know how to put them all together. Thanks for watching. I'm going to do question 3e later on today.